Greetings, everybody. This is Eric Andelin, Senior Workflow Specialist with SimActive, and you're joining us for the webinar, RTK, PPK, or GCPs, which one do you need? And with me today is David Alamillo, our Senior Photogrammetry Specialist here at SimActive. You may be familiar with him, you may not have seen him, but you may have talked to him. He certainly helps out a lot of times when people get in sticky situations. David, say hi.
Hey guys, and thank you again, Eric, for having me here on this next episode.
Yep.
Hello to everyone joining us today. Very happy to be here.
In this webinar, we're going to talk about RTK, PPK, and GCPs. We always get that question from people because RTK is being sold on most drones these days, or some type of PPK solution. But it always seems like the driver is, well, we don't need control, or we need a lot less control. And that's not necessarily true. And in fact, if you're doing RTK, you're already out there with survey equipment. So what's the harm of getting control points?
Exactly.
Yeah. So, David, fill everybody in on what your role is at SimActive, what you're doing, what your daily operations are.
Sure. Again, thank you for having me here. I am the photogrammetry specialist here at SimActive, working day to day with Correlator 3D. I mostly get your emails when something's not working or perhaps issues with workflow. I think the main thing that I received on a daily basis is, David, my control is off. David, my RTK solution's not working. Or some cases it's like, hey, how do you import images that have an altitude offset,
Yes.
So it varies, but I would have to say they're mostly workflow related. So I'm always very happy to lend a hand and always help you guys, with those workflow related issues and tackle, basically issues that are pretty simple as importing images all the way down to reviewing your project in GCPs and helping you guys get the best out of Correlator 3D. So again, that's a little bit of the day-to-day activities that we do.
Yep, great. And David and I go back and forth throughout the course of the day. If he runs into a speed bump, I can certainly help out, or if he needs, somebody to review data, I'm there for him as well. So the topics today, or what we will learn, are, a little bit about RTK. What's the difference between RTK and PPK? And don't get upset if we don't hit everything, because there are a lot of differences, but there are, a few that really matter. The next would be how RTK and PPK affect aerial triangulation and our bundle adjustments. Followed by, when are GCPs needed? That's a trick question, folks. And then, how is accuracy validated? So let's first start off with a little bit about the differences between RTK and PPK, and I'll name some that I know. David, feel free to elaborate.
Sure.
Everybody, in all honesty, I haven't put a drone in the air in the last 2 years, but I did it quite a bit way before then, and I've been involved in aerial photography and mapping since I was a wee little 16-year-old. So way before RTK and PPK.
I was going to point that out.
Yeah, exactly. Or digital cameras. So let's start with some realities. RTK provides corrections during flight, okay? So you may think that's faster, but hang on. PPK does processing the corrections after flight. So, keep that in mind. So a little difference there. RTK requires a constant connection between the base station and the drone being the rover. So where that becomes important is that if you lose connection, you've lost your potential to provide EXIF information for the images, and you most likely will have to restart your process, start from the beginning, and fly over. So you need to be aware of that when you're running an RTK-based drone, and it does happen. Sometimes the wing dips, and all of a sudden the drone loses connection, and it's headed home, and you got to start all over again. So consider that. PPK doesn't require that connection between the drone and the receiver. It's collecting from somewhere else. They're both collecting, actually. And then we talk about range. RTK has a shorter range. Again, in the drone world, you're not supposed to be going beyond line of sight without permission to do that. So that shorter range may not matter, especially if you have control on site. Again, and your base is on a known control point, you're probably in good shape as long as your PDOP is good and you're not losing signal over trees and things like that. So it's not a bad thing that an RTK has a shorter range. And then the opposite of that, PPK has a longer range because you're pulling information from a continuously operating reference station, a core station, or something like that, or some other operating station. So is your drone, and they're both pulling it at the same time. So just corrections needs to be done afterwards. Did I miss anything there? That you might want to highlight?
No, you nailed it. Nailed it, Eric. I think those are, and we go over these conversations with a couple of customers, sometimes with the RTK solution when they lose connectivity out in the field. And they come back into the office and realize that, it was a very difficult terrain. I always tell them to factor in the obstacles in the environment. In order to do RTK, I mean, some folks said, hey, I flew it where, it was basically flat, no issues with terrain, no mountains, no trees. It worked like a charm when they did the demonstration. Once I got out into the world, into a little bit more challenging terrain, that's where I started to see inconsistencies and basically losing signal and issues start to arise. So that's something to always take in consideration is, the environment and the conditions you're flying. And most recently, one of our colleagues, Thomas, mentioned to me that there was a solar flare that was actually affecting a couple of systems. So we did have a consistent number of customers that ran into this issues almost simultaneously and said, this is related to an environment issue. I mean, it's not necessarily all RTK systems went down at the same time, but it was pretty consistent. Well, so again, it's something that, absolutely, you nailed it. I think those are the factors to consider.
Yeah. Now this would affect RTK and PPK just as well if there was a knockout of the signal, or if you went into an area where you're flying around over by NASA. Somehow you got permission to be there, and they bounce the signal or they block it. In a big time urban canyon environment, you're going to run into those kind of issues. I always remember prior to drones and after photogrammetry, somewhere in the middle, I did a lot of work with mobile LiDAR systems and, trying to maintain lock at, 20 feet off the ground, going through all kinds of terrain. Every time you went under a bridge, you blew out your positioning. So, and, we were always constantly watching PDOP. How many, we got to have, 13 satellites, 11 satellites, whatever, to collect good data. Yeah. Now, one of the things I mentioned is that RTK is real-time kinematic. It's capturing data real-time. So when you land, theoretically, you could run off with corrected EXIF information on your aircraft and your image positions, and be off to the races. But that's not the best solution. You really need to wait for the ephemeris data to come back with an even more corrected solution, and then apply that to your image positions. So to say RTK is real time and it's as good as PPK, not necessarily. If you just take it and run with it, you're not doing yourself any favors, especially if you want to hold that in your processing. You always want the best solution, and the best solution is going to take you as much time as it is to wait for the PPK information. So keep that in mind. Let's see, what else? A loss of connection or drop signal, again, with RTK may require you to do a complete reflight. So, as with every survey, you may have a junior person out there who's not paying attention, and they kick over a cable or something like that. Or I've done it too. We've got an antenna on top of a truck, and you open the door and you shut the door, and all of a sudden that antenna falls over and you're done. So there's a lot of reasons, that you could lose a connection. And other things, again, RTK requires survey from the start. I mean, you're going to have to go out there and set up a base station, and again, consider the drone as a rover. You might as well have another one out there collecting GCPs. There's no reason not to. So something to consider. Whereas if you're doing PPK, absolutely, again, you still want GCPs. So you may not collect them at the same time, but there is survey involved, and you're going to go out and collect GCPs at some point. So, is there a super big benefit to, having a PPK solution where you don't necessarily have to have survey on site? I don't know. Depends on how much you trust that solution. And then, the longer baselines on PPK can create their own kind of drama. So, even when you're doing that, even when you're tying to a reference station or something like that, you kind of want to keep it closer. Just be aware of that.
That's a good recommendation, actually.
Yeah.
For PPK, I think that's a very important point, because a lot of people are confident in the larger baselines and tend to go extreme on it. And then they realize, oh, no, I can't go that extreme.
Yeah.
And I know it depends on the system they're running and on the hardware and equipment, but yeah, that's something that I see that people with PPK solutions get more comfortable with. And that's a very good point you just made.
Yeah. But, in the end, they both work well. If everything goes great, you can get, centimeter level, sub-centimeter level positions for your imagery. So that is X, Y, and Z. And you can hold to those in your AT process and your bundle adjustment if you would like. And we'll get into that here in a minute. Another thing is, don't forget geoid offsets. David will talk about that, but people will come in all the time, and if you see a consistent error across your project, which you're going to need control to see, you probably got a geoid offset issue. That's probably all it is. But you have to consider that. Now, again, I'm no longer a surveyor. I was that in the Army, and believe me, we didn't have RTK or PPK back then in those days. So I bow to those that do survey. If I missed anything, please feel free to leave a comment, put it here in the webinar, and I'm as much as ready to be schooled as I am to educate. So, feel free to jump in if you have any additional comments about that. So, David, let's pop open Correlated 3D and start going through what a project would look like.
Cool. Let's go ahead and I'll share my project, my screen. And again, thank you again to Rambal and Jason, who provided this amazing data set. And we had a call with him just a couple of weeks ago, and it was really, really good to know exactly what he was battling as far as his RTK system versus setting out control. So as soon as he and I started getting in the conversation, I immediately knew this was the data set to show you guys today. So again, thank you, Jason. Quick shout out to you, and thank you for letting us use that data set today. This is data coming in from a DJI SendMuse P1, RTK enabled. And we also have a series of GCPs. So we had a series of 9 GCPs collected. And one of the things that stood out was, after going through the processing, we did our standard RTK processing, and I'll cover that here in a minute. And just to give you guys a quick overview, we thought we could improve the results from where they were using the GCPs, not as checkpoints, but as GCPs. So therefore, we switched them during our call, and voila, we got better results. So he knew actually that these results were better using GCPs, but he wanted to actually see what the software could do. And when they're having to initiate a brand new project, how we can switch from one solution to another. So I have both today, and we're going to dive into some specifics. So anyway, just wanted to highlight that quick overview as far as the data and a little bit of background on what we're going to be seeing today. Anyway, Eric, anything else you might want to point out at this stage?
No. Honestly, that's where we needed to start. It's always good to give people an idea of, where the data set's coming from and what challenges they may have had. So continue on.
Awesome. Well, the first thing we're going to cover is, as you were mentioning during our call, is bundle adjustments. A lot of customers go through the different workflows inside Correlator, and one of that it's very, very popular is the automated workflow. However, as you know, and our folks out there on the call knows, they have to go through the process of tagging their GCPs first. So for all your folks out there that are tagging GCPs, that have GCPs in your solution or checkpoints, we're going to go first through the AT module, which is our aerial triangulation module. Let's go ahead and click our triangulation module. That will bring in, of course, as you guys can see here on the screen, all the steps already finalized. But what we're going to focus on today, as Eric was mentioning, will be the different options you have to run your bundle adjustment. Just a quick recap. You guys know the first step in the process will be to do your tie points, and the software will prompt you to do your tie points if they're not done yet. The second step is your bundle adjustment. So I'm going to highlight here. You guys are seeing my mouse and cursor going over the bundle adjustment tool. I'm going to click, and we're going to get the bundle adjustment settings. And the first thing we're going to cover, of course, based on our call, is going to be the different options we have. So by default, what do we get? The EU adjustments are going to be full AT unconstrained, and this is going to be set by default every time you guys open this tool. From this, we can open up the drop-down menu and see we have other options in there, all the way from none, bore site calibration, full AT constrained, or in this case, to the topic, RTK PPK assisted. So I'm going to start with the unconstrained, and I know for all your folks that we've done demos with, you're probably tired of hearing this, but I like this option because it gives us the best solution the software can immediately. So it will do all the adjustments for you guys on X, Y, Z, omega, P, kappa. So it gives you guys a very good overview of the project. I love to run it even if I'm running an RTK PPK assisted actually as a first step. And that's something I do just to see how good the project is coming in. So I always will run the EU adjustment, and I can always delete the step, of course. But this is the very first option that we have in the system and that we have in the software. Really tied to that, and all your folks out there with medium large format sensors will probably be more familiar with our full AT constrained, which will give you a little bit more options as far as what can you guys do. So if we go to the cogwheel now, we'll open this, and you'll see for the EO parameters, now you have an uncertainty you can adjust. So I know for all you guys running metric sensors out there, the uncertainty value, of course, could go 1 foot, 2 feet on X, Y, Z, and then of course run uncertainty values for your omega P kappa. So all you folks out there are very, very, very familiar with it. And of course, most of our drone folks sometimes don't go into the settings, as we'll probably get into the topics IMU. And I know you're probably going to talk a little bit more about it, Eric, because it's a very popular topic, especially IMU with drone systems and how good or accurate they are. But these are the main two options that we will work with. And then I will touch base on the RTK system here lastly. But I don't know, do you have any comments on any of those two, Eric?
Just wanted to briefly cover that. Like you said, we have unconstrained, which is honestly the best option, especially if you have, obviously you need ground control points to do that, but the unconstrained solution basically says, hey, we're putting all the weight on the ground control points, and we're going to make corrections to the image positions based on the AT and the bundle adjustment. So starting from the ground up, the accuracy is down here, we go up into the air and we make the corrections. So that's how that works. Yep. Full AT constrained. Honestly, that's for calibrated aerial mapping cameras, large and medium format, that have high quality airborne GPS and, a IMU. So that's the reason that we have full AT constrained. Then we've created an option called RTK PPK assisted. The reason we did that is because almost every drone out there might have a really good, GPS solution, but most likely doesn't have a high quality IMU. So what the software is doing is the software is basically saying, we'll hold the XYZ values, the image positions, but we're going to let omega kappa phi, which you would normally get from an IMU, float, or at least allow you to float it. That's going to be your best chance to get a good solution with a drone-based system. Now, again, in full AT constrained, it's going to hold omega kappa phi as well, because it's assuming you've got a high-end IMU. And therefore, you're going to get good results out of that. But just like I said, if we ran full AT unconstrained, it's basing everything on the ground control points. If you ran RTK PPK assisted or full AT constrained, it's going to ignore the ground control points if they're not there and create a solution from the top down. And where we start to see problems is if you've got ground control and you've measured that and you've got, an AT solution, AT constrained or RTK PPK assisted that you're telling the bundle adjustment to hold, if one of them's wrong, it's going to cause a problem. In all reality, I can tell you that in most cases, the problem is going to be with the positioning of the aircraft, not with the survey. But we can see that. So, go ahead and proceed a little bit there, David.
Sure, and thank you for covering the RTK portion of things. As you mentioned, it's a lot of people ask, and this is a very good stopping point. If I already ran, Eric, my EO adjustments full AT unconstrained, and halfway through the processing, I say, hey, no, but you know what? Let's do RTK PPK assisted. Will it overwrite my previous step? And the answer is no. They already been corrected. Therefore, we would have to delete the steps and begin with that specific bundle adjustment. So I like to point out that whatever bundle adjustment you start with, you'll always have that in the step, and it will actually produce a report telling you the results of that step. In this case, if I ran this data set first, as I mentioned before, full AT unconstrained, understanding this is an RTK PPK assisted data set, I can always delete the step and then obviously use my RTK PPK assisted bundle adjustment. But important step, you have to delete that step that you did previously as a full AT unconstrained. So that's something that I always like to mention to the folks out there, so there's no confusion that we're overwriting data. It's actually just refining rather than overwriting.
Right. So, as we're talking about how RTK and PPK affect aerial triangulation, that, we can look at that there. Now, it says right there that we have ground control points. And they were measured, and there is a couple, I think you have a couple of them as GCPs. But with an RTK or PPK solution, you should be looking at those as checkpoints first. So all of your GCPs should be checkpoints. And when you run that solution, if you're right on, then your solution, then your RTK or PPK is very good. But if you're off and it's consistent, then you've probably got a geoid offset issue. But that's fixable. If they're just
right,
all out of whack, then your RTK or PPK solution shouldn't be trusted. And at that point, we can start looking at changing the checkpoints to actual ground control points. And again, going back to the unconstrained solution to get you the best data set.
And let's take a look at that workflow you just described. So we'll run our first bundle adjustment, RTK PPK assisted unconstrained sensor calibration. So we'll basically do a calibration on the sensor. Ground control points, as you mentioned, these ground control points have already been imported as checkpoints, and I will show you exactly how and where to do that, and process. So that's going to output a report for us, and we're going to take a look at it. Before we do that, let me show you really quick how to import the GCPs as GCPs or checkpoints. In this case, if I plan to use this RTK and use just those GCPs as checkpoints, you can drop down the menu on GCP type, and then you can select checkpoints. At this stage, every single point you import are going to be imported under your checkpoint section in the tree. If you decide to go with GCPs, you can always select the GCP type, which is by default, and then they will be imported as GCPs. So let's take a look at here. As you mentioned, we have a couple of GCPs, and I've actually made some of these checkpoints GCPs. So you guys can see I did 1 and 5. and I left all the rest as checkpoints. The first run that I actually did all of them as checkpoints. And let's take a look at the report.
Yeah, let me comment on that. The way that Correlator 3D treats these is if they're ground control points, it's going to use them in the solution. If they're checkpoints, it's just going to measure against them and see how they fit the solution. They will not affect the solutions. That's something that people need to realize.
Yes, absolutely right. And maybe while you're here still on this topic is how can I make one or the other? I wanted to cover that later, but probably it's a good stopping point.
Yeah.
If I hover over any of the points, either a GCP or a checkpoint, I'll get a little pencil, which is our edit point tool. And if we click the edit point tool, we'll immediately see the images that were used to tag. But what I want to guide you guys to is to the type. Same as what we imported. If you go to the type section, drop down the menu, I can update this point to a checkpoint, save and close, and then you'll basically see this point down here into your checkpoint section. So that's how you basically upgrade or quote unquote downgrade from a checkpoint to a GCP. And now that being said, we're going to go and check our first report with obviously our 9 checkpoints, RTK PPK assisted. So let's take a look at this report and we'll make it just a tiny bit bigger for you guys out there. Regular project summary, project type, the elevation units, total number of images. Quality assessment is excellent. And of course, something that we always look at is the projection error, less than half a pixel, looks pretty good. About 109 type points per image. What we're going to focus on is on the right-hand side where we have our checkpoints. We have our average XY error, which is actually pretty good. And then we have, I'll read it for you guys out there listening, it's 0.020 meters. And then we have our RMSE error, which is 0.291 meters. And here is where the conversation starts, because actually Jason pointed out this to us, and he was pretty familiar with the RMSE error that he got for this project. And something he said, and I'll quote him again, was, when we ran this, we have checkpoints and we have ground control points. So we decided to run this with ground control points, and dun drum roll, got better results. So let's actually dive into each one of those specific checkpoints. So I'm going to go all the way to the bottom of the report, and we're going to see this live. And let's go all the way to the last page. Here we go. So we have, you can see the type. That's why we know it's a checkpoint. It's CP. We got our X, Y, Z, overall X, Y, Z, and then pixels.
And hang on.
So you can see it's pretty consistent. Sorry, go ahead, Eric.
Hang on, David. This, just to remind the viewers or listeners, this is run RTK PPK assisted. So we are constraining X, Y, Z up in the air, correct?
Absolutely.
Yep.
And now what we're seeing here, you guys can see it's pretty consistent across the board, across C. Checkpoint number 1, 0.301 meters. Checkpoint number 2, 3.08. 3, checkpoint number 3, 2.76. And so on and so forth if we go to the list, especially for our listeners out there. And as we were discussing the results, he said it's a pretty good result. Most folks would be happy with it and be like, let's continue on with the processing. However, here's where the curiosity starts and says, what about if we switch these over to GCPs? And rather than running this RTK PPK assisted, we run a full ATM constrained. So we did the test live, and of course this opens up the topic for some conversation, right? So what I did is come back into the tool. You can obviously delete the step, so you can delete that step and go back to your initial after your type points. Come into the bundle adjustment, change from EO adjustment to full ATM constrained. Use your ground control points, process. Quick note though, before we do that, remember, we need to adjust these checkpoints to be ground control points. So that's something that we had to do in the process, and then run basically the settings as I mentioned before. Once we did that, we're going to output the next report. I want you guys to see this in step 3. And here we go. We have that ground control point, average XY error, 0.001 meters. Average RMSE error is 0.005 meters. So here's where I'm going to open the topic and Eric, feel free to chime in with comments. I know you were the one who reviewed this project for me, so and you were the first one to point this out even before we had the meeting with Jason. So again, I'll let you chime in and give me your feedback on this.
Well, what it points out is that there was enough error in the RTK PPK solution, or where the antenna was measured from, that we saw a consistent error of around 0.3 in the vertical. Yep. So you could do one of two things. You could make an adjustment to the RTK PPK solution, just like you would a geoid offset, and raise the whole thing up, basically that 0.3. There's nothing wrong with that. And then rerun it against the checkpoints, and you're probably going to see that error disappear. Again, because it was consistent on the board, you could do that. But what it's telling you is that you've got a problem with your RTK PPK solution, again, either maybe in where the antenna was measured or a little bit of geoid offset. I mean, it could be anything.
Yes.
The scary part is it could be anything. And if you didn't have any checkpoints or control to measure against, you would never know. Which is why we say you always have to have survey. And then again, the other option is, like David did in this case, take a handful of them, turn them into control points, leave the others as checkpoints, and then run the solution full AT unconstrained. So what it's doing is it's saying, again, we start with the ground control, this is correct, and we make adjustments going up to find the photo centers within the software. And you can bet they're 0.3 higher than they were in the RTK PPK solution. So that's something to be aware of and to know how to check what's going on.
That consistent offset, as you mentioned, it's something that I see very often, especially when geoids are applied. And there are very clean ways of taking care of that. Now, of course, some final steps here is to review the quality report at the end, and we can actually see the 2 GCPs that were updated, and then the rest of the checkpoints and what solutions we got from that. So that's again, you can always find your quality report in PDF format. It's within the IO folder, and you can really dive into other specific files we have within that folder. So if this specific report is something that you're focusing on, that would be great. But if you really want to dive deeper into the AT, you can always find additional resources within that folder. Again, this is something that we did live on the call, and I have to say, Jason was pretty happy with the results, and we basically were able to discuss a little bit more on what solutions Correlator has as far as the bundle adjustment tools and the benefit of the GCPs out in the field. He was pretty adamant about this, and he said, you can call me old school, but I always prefer to take out my GCPs out in the field, and I have to say I'm there with you, Jason. So
yeah,
again, I don't know, Eric, anything else?
Yeah, the comment I would make was, after running this solution, if one or two of the GCPs checkpoints was still coming out way off, then I'd start to question the survey. But in this case, and believe me, I'm not questioning the ability of the surveyors to do the work, because I used to do that work as well, and sometimes you fat finger a number or something like that, and you just one gets by. But you can see that, and you can correct for that. If you don't have any control, then you don't know whether your data is actually on the ground or not. So that becomes the challenge in just using a PPK or RTK based solution. Now, that said, there are plenty of scenarios where the accuracy from such a system is good enough, but that has to be conveyed to the customer either when you're doing the work, or the customer has to convey it to you when they're contracting you to do the work. For example, if you're out doing large chunks of forest in northern Canada and there's no access or ability to put control in, PPK is going to be a good solution. On top of that, if you've got, again, a calibrated mapping camera, IMU, great PPK airborne GPS solution, you can certainly get very, very good results. and they can be consistent. But the only way you can validate that is against control points. And if you have a bore site or a test field and you do that consistently, then you probably go to your customer and say, I can meet an accuracy to plus or minus this with just a PPK solution. And if just a PPK solution is good enough, you've limited some of the cost of control, then maybe that's what folks want. And yes, you can probably stretch out your control a little bit with such a solution, but there are many more factors involved, again, including that IMU, including that calibrated mapping camera, that you should consider if you're going to do something like that. And a lot of the people that are doing this are either a function of a survey company or a branch of a survey company, or have surveyors involved, or they're surveyors on the project. What is the real cost of adding control versus messing something up? I guarantee you nobody is going to argue their solution in the air is going to beat a surveyor on the ground. It's just not going to happen. So, in areas where survey is feasible, then survey needs to be done. The number of control points you want to use or the number of checkpoints you want to use, that's a comfort level. That's something that you, as the person doing the acquisition, has to get comfortable with before you start laying things out like that. It's not the old days of every third stereo model has to have a control point. Those days are gone, because the number of cameras in the systems out there are so variable that you just couldn't dictate something like that. Those are the things I wanted to point out in this. At this point, a DJI drone with RTK is not that expensive, so it's not that big a deal. But you actually, probably the receiver on the ground that you have that's the survey equipment is more expensive than all of that. It makes sense to collect those GCPs. Now, one other point is, even in the report that David created, that's using the ground control again to make the solution and to have everything fit the model as it should. If there's error in that ground control, it's not going to see it. If you did it, with GPS observations and those are all, 0.3 of a foot off in the first place, you have to include that, going down the road in your reports to your customers. But just be aware of that as well.
That's a good point. Yeah, absolutely.
I like this specific example because it shows that you can start off, again, in RTK PPK mode and measure against the checkpoints. And it shows you that it's off, but that it's consistently off. And that tells you that your solution in the air is off more than likely than the survey. Or once we process it unconstrained to the ground control, that error goes away. So that's telling you where your error is up in the RTK PPK solution. So be aware of that. And again, you have two options. You could, knowing that it's 0.3 in this case, vertically off, you could go in and David, why don't you just pop out and show them when we set up a project where you would put that offset?
Sure, absolutely. Let's go ahead and open up a brand new project, and let's load up some images here for 1 minute. There we go. This would be the section right here under parameters where you would adjust that altitude offset. Could be 20 meters, 25 meters. And this would obviously assist in that process. And you would, if you're redoing this, you can actually calculate that offset as we were talking earlier with your checkpoints, and basically convert that offset and apply it to all your images. That's something that we discuss as well with most of our customers as far as setting up your project. This is something, a part that it's ignored. So we're working with geoid and talking about geoid ondulation. That's what you want to do. You want to calculate that geoid ondulation and type it in here as an altitude offset. And that would allow you to then get consistent results during your bundle adjustment.
Yes. And, again, I don't really want to go too deep into RTK and PPK and how you process out your solution on that end. But as part of that, you should be considering whether or not you've got geoid offset to deal with. You can go to the NGS website, put in, the lat long of your project, and it'll give you that offset. So, and then you can just add that to the solution. Some of the software that does that processing automatically includes that. So just be aware of that. I remember the first time I did a project, I'm like, why the heck am I 18 feet off consistently? Geoid offset. So this is
it's consistent.
Yeah, that's why I'm not a surveyor anymore, because I have to learn those things. But we have that here. So if perhaps your software doesn't automatically do that in the processing of the solution, you can add it here, which is an ad we put in about 2 years ago as these things started to get more popular. So David, I think that wraps it up. You've got a great example project, and we appreciate the client for letting us share it. Again, what I'd like to point out is that Correlator 3D can handle it any way you provide it. And not only that, but if you run into an issue, and David, you can attest to this, if you run into an issue, the fastest thing to do is go full ATN constrained, and that'll at least help you find your problem.
Absolutely. And that's what I mentioned earlier. I run a full ATN constraint, even knowing that it's an RTK PPK solution. I spot a lot of issues doing this, and I go through the report and see if there's a consistency in the image movement and XYZ, or basically if the solution is not that good. But it's a very good starting point, gentlemen.
So I think we've covered everything. If you have questions, or if you've left a question, we'll make sure, or have an opinion and want to correct me, because that's an easy thing to do. Please, yes. Please leave it in the comments, or shoot us an email. When we finish the webinar, we'll get back to you with those answers. I'd like to again thank David for participating with me. He's the one that runs into these problems, and he's the one that helps folks work through these solutions. It's mapping. Sometimes we get frustrated, and we just need a little push in the right direction to find a solution we're working with. And David's here to help everybody do that. David, thank you very much.
It's always a pleasure, Eric. Thank you very much for having me here. And again, a big shout out to the entire team at SimActive. We all do our part here, and thank you very much, Eric, because you're a big help as well to our team. So thank you.
All right. So with that, we'll conclude the webinar. Thanks, everybody. This webinar, as well as all previous webinars and our podcast, can be found on our website, simactive.com, under the Learning tab.